Hello everyone. Today let's go through a revision paper. This is a real exam paper from May or June 2019 here. So in the previous video, we have covered the first 5 MCQs. So now we'll cover the next 5 MCQ, okay, from question 6 onwards. Okay, let's look at this question here. Now they say the story goes like this. It says a car travels along a straight horizontal road. The graph shows the velocity, variation of velocity with time for the first 6 seconds there, okay? So it's velocity versus the time in seconds, so the units are right. All right, and they say the brakes of the car applied from 1 second to 4 seconds. So because of the brakes applied, we have a decrease in velocity, a uniform decrease. And they ask for how far does a car travel while the brakes are applied there. Okay, so for velocity time graph, the area under the graph, okay? Area under the graph gives us the distance traveled there, okay? So from 1 second to 4 seconds, this is area we want. Now I'm gonna read from the graph. This one is gonna be 22, okay? 22 here. This one is gonna be 8, okay? 8 meters per second. So this whole trapezium here and the area, the distance, sorry, the time here is 3 seconds here. So the area here is going to be half of top plus bottom times the height, okay? So it's half times 30 times 3. That will give us exactly 45 meters there. Okay, so the tricky part is that first of all, we only care about this particular time interval, not the whole time interval from 0 to 6. Second of all, I have to read the graphs carefully there. Also from here, okay, sometimes the question might be tricky. They want to change the value here 0, change other values. Then we have to recalculate our area again. So this one is starting from 0. So the area on the graph is going to be our distance traveled there. Okay, so the final answer is B there. Now let's move on to question 7 here, okay? So they say a stone is thrown horizontally from top of a cliff and falls into the sea sometime later. So if you imagine that the motion looks like this, okay, so is this a stone here, fly all the way, okay, to the sea there. It's a sea here. Now this is going to be a projectile motion, right? So horizontal velocity is going to be constant, all right, and a vertical velocity starting from 0 and starting from 0 and going to increase. Okay, increase a bigger amount, okay, until it goes before it goes to the sea there. Okay, so which graph gives us horizontal, V horizontal, okay, to be constant, and V vertical to be increasing? So it's gonna be choice D there, okay? So vertical here, V horizontal is a constant value, and V vertical is keep increasing, okay, from 0 all the way to, let's say, 10, 20, 30, etc. Okay, so this answer is choice D there. All other graphs, okay, V vertical, V horizontal here, VH, have some changes value, which is not possible for a projectile motion like this. Okay, that's why A, B, C are all wrong there. Okay. All right, that's for question 7. Now let's move on to question 8 here. This one is about positive charge, okay, of this charge in a uniform electric field or field strength of this is our E value here. E is a vector there. Okay, how much more must be done on the charge in order to move a distance of 4 millimeters, which is 4.0 times 10 to the power 3 minus 3 meters in opposite direction to the direction of the field. So we can draw out a schematic diagram with a uniform electric field, positive, negative. So electric field goes this way. This is the direction of electric field. And they say the positive charge here, is going to move in the opposite direction, all right, the motion in this way. Okay, so as we can imagine that we have to, there must be someone pulling this positive charge, right, to go against the electric field in order to get closer to the positive plate. We can sense that there must be some repulsion between the positive charges and this and this is positive plate there, okay? So let's look at the work done here, okay? Work done is equal to change in electric potential energy That's equals to charge times change in electric potential. That's also equals to, how do you get that change in potential? That's going to be, remember that electric field strength equals to change in electric potential over change in distance. So our change in potential, that's going to equal to E times delta D there. Okay, so Q times E times delta D. So that's going to be the derived equation there. Now we are ready to sub in the value. So it's going to be 2.6 times 10 to the power minus 8. E here is going to be 300,000. And then the distance here is 4.0 times 10 to the minus 3. So put everything together, we get 3.1 times 10 to the power minus 5 joules. Okay, so that we find also choice A there. Okay, so what the tricky parts here? Now, first of all, we should recognize that it's about energy approach. Okay, and then the E here, okay, sometimes if you're unfamiliar with this equation, we might find it hard to change to get delta V from the E times delta D there. Okay, all time together will give us this value. So that's the work done there, okay, choice A there. Okay, now let's move on to question 9 here. Right. Okay, so this one you say each diagram illustrates a pair of forces equal magnitude. Which diagram give an example of pair of forces described by Newton's third law? Newton's third law is action reaction force here, okay? So what will form an action reaction force? First of all, the two forces there, okay? Two forces must be equal in magnitude, and opposite in direction. Second criteria, they must act on two different objects. Okay, so that's why if you add two different objects, they cannot cancel each other out. Okay, cannot cancel each other out. Cannot cancel each other. Okay, so that's why here. Okay, that's why choice A is going to be acting on the same object. No. Okay, acting on the same object. No. This one acting on the same object. No. Okay, only this one. All right. So choice B is acting on two different objects and equal and opposite. All right. So for example, if a force attraction with 10 Newton, here is also 10 Newton. But these two 10 Newton are not going to be cancel each other out. Okay, no, because acting on two different objects. Okay, acting on Earth and Moon there. Okay, so it's very tricky. The two requirements are very important here. Okay, the first one, second one. Okay, in order for us to distinguish the pair of Newton's third law forces there. Okay, that's for question 9. Now let's move on to question 10 there. Okay, so for a stone dropped from a tall building, air resistance is significant. The variation of distance falls with time is shown by a dashed line here, the first stone there. So if it falls there, okay, so as weight, we also have air resistance, which proportional to speed there. So when it reach terminal velocity here, okay, K times V terminal equals to M times G. So our V terminal equals to M times G over K, where K is a constant there, okay? So that tells us that terminal velocity is proportional to mass if everything else is the same. If the same dimensions of that, then K is the same, G is the same, then so when mass increases, this one also increases, and vice versa. Okay, if a second object, okay, if your mass is smaller, then V terminal is also be smaller. So what do we expect to see there? We expect in a VT diagram, okay, velocity time graph, original first stone will be something like this, with terminal velocity, that's the first one. For the second one, the gradient is the same, and then it reached the second, reach the lower terminal velocity. So in this case, which one gives us original same gradient and becomes a lower gradient? Lower gradient means that smaller speed there, smaller terminal speed. So in this case, it's choice C there, okay? There's some constant gradient there, okay? Lower gradient compared to the past of first stone. Okay, why is not part D there? Okay, you see the straight line for part D, okay? So that means the velocity pretty much constant. No, okay, this velocity is constant. That does not match the motion of second stone. So that's why D is also wrong. A and B are wrong because the gradient, okay, the gradient in the end are not going to be, the gradient is velocity, and velocity is higher than first storm. That's not right. Okay, so that's why it's the final answer is choice C there. Okay, that's for these 5 MCQs. Hope that helped you a little bit in your revisions. That's for all for today.